Good morning, everyone, and welcome to this lecture. This is lecture number 14 and probably one of the last lectures in rotation. Maybe one lecture and we would be done with the rotation. But remember, we are in the most difficult part of rotation, as it seems, because now the bodies are going to, and we have seen in the previous class, the bodies are going to translate and the same body is going to rotate. Translate as well as rotate. We had seen in the previous class how we can find out the relation between various accelerations, and these are very difficult questions which we had solved. We had solved the most difficult part of these questions, and the most difficult part of this question was to understand the relation between the various accelerations. Now, if you understand that relation, and we had done some really great questions. Do you remember all of these questions? Anyone having any doubt on any of these questions? Okay, I'll wait for a minute. So, as I was telling you, we had done some questions where we had found out the relation between the various accelerations. That is probably the most difficult part of understanding this motion. And it was basically understanding that there is no slipping, so the accelerations must be same. That is one part. As I told you, that is the most difficult part. Now let us come to the part where we had, as you can see in this question, we had found out the relation between A and alpha and R. But they will not ask you just simply to find out the relation between A, alpha and R. They will ask us to find out the value of A, alpha and R. That will only come in JEE Advanced. It will not come in JEE Main probably. So how do you find out the value of alpha 1, or there can be more than two bodies which are rolling, or there can be one body which is translating, the rolling body is also translating. How will you find out the various accelerations, and how will you find out the various angular accelerations? So then you will have to make equations for this body. How are you going to make equations for this body? And nothing has changed. Nothing will change in the equation. The equation remains exactly how they were supposed to be. So you will make the equations. Now, these are the equations that you can make, and remember how they are made. You can make one equation of torque. There would be some force that would be causing the body to rotate about the center of mass. Bodies are going to rotate about their center of mass, as I told you. So the first equation that you can always write will be torque about the center of mass will be moment of inertia about the center of mass into alpha. We understand this? Equation number one. Then the second equation would be there would be external forces acting on the body. Now remember, this F external will be equal to M into ACM. We have already seen that. Yes or no? The external forces on the body will be mass into the acceleration of the center of mass. These are the two basic equations that we'll be requiring. Apart from that, they can ask you what is the momentum of the system. So momentum of the system is mass of the body into velocity of the center of mass. Total kinetic energy, we have found it out so many times. Half mvcm square plus half I omega square. Angular momentum about the center of mass, you can find out angular momentum ICM. This is the spin angular momentum. Sometimes we might also be interested in finding out the angular momentum about some point, and basically this point A is going to be your point of contact. There are some questions which can be solved directly by this. I will tell you those questions. So you might have to find out the angular momentum about the point of contact. So this is the way you can find out the angular momentum about the point of contact. We have all seen this in separate cases in different ways. Yes or no? This is not equations which we have not used before. We have used this equation before, but right now what we got to do is we would have to use this equation on the same body, which is rolling, which is translating, as well as which is in pure rotation. Now, one thing that you always see here, that all the equations are made for the center of mass. And remember, that is the thing that you must remember whenever you apply this equation, especially the equation of torque, especially this one. This equation should only be applied about the center of mass. Remember this. This equation should only be applied about the center of mass. You cannot apply this equation about the instantaneous center of rotation about the point A, because it does not work. And how it does not work, this is just to show you that it does not work about the point of contact. So never apply this torque equation about the point of contact. Always apply this about the center of mass. That is why I am giving you this as a separate point. Never apply this equation about any other point rather than your center of mass. You must always apply this torque wala equation about the center of mass. Do we understand this? Okay, I'll give you a minute to note this down. Once you are done, just signal and I will continue. If you have any doubts in any equation, please let me know. I hope every equation is clear. Yes or no? Okay. Once you note it down, please let me know. Shall we move ahead then? Okay. Now, one of the questions we have already solved, and this is the question that you've not solved. Actually, we got the relation between alpha and A. Now, let us assume that this is a disk. This is a disk of mass m. It could be a sphere also, but this looks good. This is a disk of mass m, and it is put like this, and I leave it. So what is going to happen with this? We have already discussed this, right? This is going to go down and it is going to rotate like this. Yes or no? We have already found the relation between A and alpha. So that is one part of the problem. But that is not the only problem that we'll have. Now you have to get the value of A and alpha for this body. How are you going to do this? Just now told you, and I want you to try it on your own and be confident that you can do it. If you're not able to do it, I'm always there to help you out. But if you can do it on your own, nothing like it. So you have 2 minutes to make the equation. See how many equations you can make. See how many unknowns are there. If your number of equations, let us say 3, and your number of unknowns, let us say 3, are same, that means you can solve this equation. If they are less, that means something is missing there. Find out that missing thing, solve those simple equations, and you are done. This is a problem for JEE Advanced. This will never come in a JEE Main paper. 2 minutes, you have. Best of luck. We remember this question, yes or no? So wherever you have written this question, you can go to the same page and then solve it. or you can draw the diagram again and then solve it. Doesn't matter. The only thing that I'm concerned about right now is that you must be able to solve it, nothing else. Shall I help you? Not able to do? Okay, then I have no choice but to solve it. So I'll have to draw a free body diagram. I have drawn the tension already. One thing that I have not drawn is the weight of gravity. So I will draw that gravity force also, mg. Okay. The first equation has to be made about the center of mass, which is the equation of torque. What is the equation of torque? Made about the center of mass. Remember, this is the tension that is causing the torque, and this is the center of mass here. What will be the torque equation? I can't speak, but I will do that part for you. So the pink equation, the torque equation is, the torque is going to rotate it. That's why it is rotating. So the torque equation is T into R. T into R is equal to I alpha. I is mr square by 2. Mr square by 2 into alpha. Also keep on counting the number of unknowns that are coming and the number of equations that you have. Right now I have 2 unknowns and 1 equation. No. I have one more equation here. I have 3 unknowns. The unknowns are A, alpha, and T. And I have only 2 equations, so I cannot solve the equation completely. So I need one more. From where that one more equation is going to come? There is an external force acting on the system because the system is accelerating. I must make that equation. Weight mg is downwards, tension T is upwards. Weight mg is downwards, tension T is upwards, and this center of mass is going to go downwards. So I will make the equation for that external force. What is the equation of that external force? Mg is downwards, A is downwards, and this T is also, T is upwards. So I make that equation. What is that equation? The green equation. Mg minus T is equal to M into A, mass into acceleration. Equation number 2. Now I have 3 unknowns, 3 equations. I'm done. I can easily solve it by any way that you feel comfortable. How I'm going to solve it? Well, this is a very simple one, so you can easily solve it. Yes or no? You can put this alpha as A by R here. This R and this R will cancel. This R and this R will cancel. Then you can add up the two equations and you have your acceleration. Add up the two equation now. So you will have T and T will get cancelled. M will cancel out from everywhere because M is constant. You will get the value of acceleration. How much is the value of acceleration are you getting? So I think 1.5 will be 3 by 2. So you will get G as 3 by 2A, or your acceleration becomes 2 by 3 times of G. That is the answer. Once you get the value of acceleration, you can find out the value of the angular acceleration. You're done. Do you understand this, or this has gone above what I'm saying? Bye-bye. Bye-bye. Huh? Understand this? Pakka? See, just read the question, understand it, and you are done. Okay, I'll give you 1 minute to solve it, to note it down. If you noted it down, let me know. We got this, yes or no? Can I take you to the next problem? So the next problem is like, again, might look very confusing. Here we have two rotating bodies. One is a pulley, as you can see, it is fixed. This is a fixed pulley. The moment of inertia of this pulley is given as I, and the radius, I mean, let us write the radius as capital R. The radius is capital R. String is one, rope is wound on this. Then I have a disc of mass m and radius small r, so that you can differentiate. This disc is falling down. This is not fixed. This is going to move down. There is no slipping happening anywhere in between. Can you find out what are the things that you can find out here? What are the things that you are going to move and rotate? The first thing that is going to rotate is this disc. Yes or no? Is this pulley? Yes or no? And the only way this can rotate is in this direction. Do we understand this? So let me call this acceleration as alpha 1. Okay. What about the disc? How is the disc going to rotate? Clockwise or anti-clockwise? How is the disc going to rotate? It cannot rotate anti-clockwise, right? There is nothing that is going to rotate it anti-clockwise. The only thing that can rotate it is clockwise. So this is clockwise. Let me call this angular acceleration as alpha 2. It will also move down. Let me call that acceleration as A. So you have three unknowns. No. You have one unknown alpha 1, one unknown alpha 2, one unknown A. Is there any more unknown here? There is this tension in the string which is unknown. So you basically have four unknowns here. And you have to find out the value of A, alpha 1, alpha 2. If you can do this, well done. If you can't do this, no problem. No one understands rotation. No one understands rotation. Trust me. Remember, there are 4 unknowns here. So there must be at least 4 equations that you have to make. You have 2 minutes to do it. Yes, anyone with any answer? Okay, let me go ahead and solve it for you. Okay, the first thing is, let us write the equations. Now, what equation I'm going to write for this yellow pulley? The only equation I can write for this yellow pulley is the torque equation. Yes or no? What is the torque equation for this yellow pulley? The weight cannot create any torque because it is hinged about the weight. So that's why I have not given the weight. There is no use of giving the weight. The only equation that you can make for this pulley is the rotation. What is the rotation wala equation? T into R, the torque, that should be equal to I into alpha. Yes or no? Alpha 1. 4 unknowns we had. We had one equation. Well done. Let us move ahead. Now let us come to this other pulley, the pink pulley. In this pink pulley, I can first of all make the torque equation. It is rotating like this. And the tension is here. Weight cannot create any torque. So what is the second equation that is coming from this pink one? T into small r. Radius is given as small r. That will be equal to I of this. M small r square by 2 into alpha 2. Yes or no? That is the second equation. Remember, I have 4 unknowns. I am successfully completed 2 equations. What is the third equation I can make? The acceleration of the center of mass is there. Then I can make the green equation. This is here. I have not written the weight. So let me write the weight. mg, green equation. This goes here. This goes here. What is the green equation? mg minus t is equal to ma. Yes or no? Now I take a deep breath and look at the equation. I have 3 equations, but I have 4 unknowns. One thing is missing. From where will I get that one thing? From where do I get that one thing? And as I told you, that one thing is the most important thing. From where do I get that one thing? Point of contact. Yes. Now I look at this point of contact. I look at this. Point here, and I look at this point, blue point. Both of them must have the same acceleration. This point has an acceleration of alpha 1 into capital R. So this blue point should also have the same acceleration, alpha 1 into R. We understand this, yes or no? This blue point has the same acceleration. This blue point is same as this blue point. So this will be equal to alpha 1 into R. We get this because it is a string and the string is moving now. Now again, this blue point and this black point, no, then this red point, they must have the same acceleration. Now this red point has an acceleration a in the downward direction because of the center of mass, and it has an acceleration alpha 2 into small r in the upward direction. Yes or no? Both the acceleration must be same. That gives me my revolutionary and the most important blue equation. This is the blue equation which everyone is confused about. I get the blue equation. What is the blue equation? Alpha 1r, remember the direction, should be equal to a minus alpha 2r, or I can write alpha 1r plus alpha 2 into small r is equal to a. 4 equations, 4 unknowns, solved. Now physics finishes here. That is all I can help out in physics. How you are going to solve is your problem. When I say your problem, I mean you have to find out the way of solving it. How do I solve it? I use a very simple thing here. See how I'm going to solve it. Look at this. I am going to find the value of alpha from here. I am going to find out the value of alpha 2 from here. I am going to find out the value of a from here. And then I am going to put everything in this equation. Now, what is the quickest way to do this? Because you will be getting this side of equation in rotation. What is the quickest way to do this? This alpha 1 will be multiplied by r. So what I will do in my head, I will multiply first equation by r. I'm just showing it to you once. I will not show it to you again. I will multiply this equation with r in my head. Then I will multiply the second equation with small r in my head. Third equation, I don't need to multiply. Now I multiply everything in my head and I write it. I multiply everything in my head and I write it. I multiply everything in my head and I write it. How does the blue equation look like now? It looks like this: tr square by I plus 1 r will get cancelled from here, ting, ting, plus t2 by m. T2 looks bad, so I will write it as 2 times t. This 2 will go there. This 2 will go there. 2t by m into r, m into small r. Because I have to find out the value of alpha 2 into r. That should be equal to g minus t by m. And from here, I should be able to get the value of t. What is the value of t? The value of t would be g divided by r square by I plus 2 by mr plus 1 by m. This looks dimensionally not so good. What mistake have I made? What mistake have I made? Dimensionally, it does not look good. 2t by m. Yeah, it should be 2t by m, but okay, I canceled this in Josh, so I should not have done that. See, a simple mistake, and the dimension goes Bhagwan ke paas. So when the dimension goes Bhagwan ke paas, the answer looks like this. See, that is how you get it. Do you understand this? This is my way of doing it. I've always done it this way. Rest is yours. Do you understand how this is done? Yes or no? If I give you another question, you would be able to tackle it. Yes or no? Yes or no? Then comes this problem, my dear friend. Lots of things in this problem have been discussed. What I'm going to do here now is just tell you that this is a disk of mass m and radius r, capital mass m and radius r. This is a disk. Can you find out the unknown quantities? Do you understand this question? You've done a part of this question. This is the most difficult question I can ever come. You have 2 minutes to get me the answer. countering any sort of problem here? Okay. So let us try to do it and see what is coming here. Okay. We have already got this relation, yes or no? We have already got this relation, yes or no? So how many unknowns are there? A1, A2, and alpha. 3 unknowns. Okay. One more unknown. 4, tension T. Right? So let us try to solve it. First of all, this block is going to move down. Yes or no? So I can straight away make this equation. What is this equation? mg minus T is equal to M into A1. That is the first equation. One equation done. Then I can make one equation for this rotation. Yes or no? This T is here and it is rotating like this with an angular velocity alpha. And this is a disk. So I can write the pink equation. What is the pink equation? T into R is equal to M R square by 2 into alpha. Two equation, two unknown. Two equation, 1, 2, 3, 4 unknowns. Let us move on to the third equation. What is the third equation? That will be for the force. T is equal to capital M into A2. Yes or no? Okay, 3 equations. Then I have one equation from here. Oops, wrong color. Then I have one equation from here. A2 is equal to alpha R. Yes or no? 4 equations. Then I have one equation from here. A1 is equal to A2 plus alpha R. I have 5 equations. Yes or no? I have 5 equations. But I have only 4 unknowns. That is good now. I have more I can make now. See, I can make more equations than the number of unknowns. Something is wrong, right? Yes or no? And what that something is not right, we will try to understand now. What that something is going to write is wrong. Something is wrong here. What's the difference between this question and this one that we did? This one, the block was the so you understand na, that pulley was hanging. Here also, this block was hanging from the rope and it was rotating and there was no slipping. There was also no slipping at the other pulley. Now, here is no slipping. Imagine putting a disc on ice, slab of ice, and applying a force onto it, will that disc rotate? Or will it just go like this? It will just slip, yes or no? It cannot rotate, yes or no? It will not rotate. That means what actually makes it rotate without slipping or rotate is actually the friction on ground. Now this disc here, depending on the condition, and we will see that condition also, there has to be some friction on ground that is going to make it roll on the ground. Do we understand this? So first of all, before going into this problem, we have to understand what are the different cases possible where a body is rolling on ground. In what all conditions can body roll on ground? And in what all condition, what type of friction? Can it roll on a smooth surface? Can it roll on a smooth surface? If it can roll on a smooth surface, what is the condition of it rolling on a smooth surface? What is the condition that it can roll on a rough surface? It all depends on whether the surface has friction or not. Do we understand this? So now to solve this question, now let us get back into the theory of this, how you can have bodies. Up till the bodies were in air, the problem did not come. Why the problem did not come? If I just tell you, this was your disc and this was your rope. This tension was not making it to rotate actually. It was the friction between this rope and the pulley which was making it to rotate. Do you understand this? It was just not the tension. If there was no tension between the pulley and the rope, this pulley could not rotate. It will just move down. Yes or no? The rope will just slip and the pulley will just go down. It cannot rotate. It can only rotate when there is friction. Now, why we did not talk about friction in this case? Because between the rope and the pulley, the friction was an internal force. Do you understand this? Between the string and this pulley, if I take it as a gear system, this pulley was an internal force. So this whatever friction this rope was applying on the pulley was applying the same on the rope. So when you take this pulley and rope as one system, actually the friction gets cancelled and it looks like it is getting rotated by the tension, but it is not getting rotated by the tension. It is getting rotated by the friction between the pulley and the string. But since there was a rope, what we have done, that friction becomes an internal force. We don't have to think about that friction. Here also in this case, there is a rope attached on the upper part. Now, because of friction between this upper part, between the rope and the pulley, it is going to rotate. Do you understand this? So this will try to rotate it. But if there is no friction on the downside, it may not just rotate. So we'll have to understand under what conditions our body is going to rotate on what type of surface. Do you get this part correct in your head? Now let me present to you some cases and try to make sense of how bodies are going to rotate and what part friction is going to play. And can you make a body rotate without friction also? So write the next heading, different cases of rolling body. Different cases of rolling bodies. First case. Now, in first case, how are we going to make the body to roll? The surface is smooth. The surface is smooth. How I can make it to roll? I give it an angular velocity, omega, and I give it a velocity v. and I give the angular velocity omega in v in such a way that v is equal to omega r, and then I leave it on the floor. You understand what I'm saying, right? I have nothing to rotate. I have this body. So what do? First, in my hands, I give it an angular velocity omega, and then I leave it on the floor, giving it a velocity v. So v becomes equal to omega r. If I leave it like this on a smooth floor, it will keep on rolling forever. Yes or no? Because beforehand, I've given it an angular velocity and I've given it a velocity v. Go and live your life, Simran. So the Simran goes and she starts to live her life. Do you understand this? There is no friction involved here. I had made the initial condition in such a way that it can start rolling straight away. So in this case, the body can roll without friction. Friction is not required in this case. You understood the first case? Now, in the second case, I do the same thing. I give it a velocity v and I rotate it with an angular velocity omega and leave it on the floor. But now the floor is not smooth. So it will not keep on rolling forever. After some time, it will stop. Why will it stop? It stops because of so-called rolling friction, which is very small, but it is there. It stops because of rolling friction. It stops because of which friction? Rolling friction, which is not in our course, so we will not discuss about it. Now, when this is rolling on this, when this is in pure rolling about this on this floor, the friction acting between this body and this surface is static friction. Why it is static friction? It is static friction because there is no slipping. This body wants to slip, but friction is not allowing it to slip. Friction is strong enough to resist slipping. And therefore, whenever a body is rolling over a rough surface, the friction between the body and the surface is always static. Remember this and keep it in your head. What are you going to remember and keep in your head? Whenever a body is in pure rolling, whenever a body is in pure rolling, whenever body is in pure rolling, friction is, what type of friction acts on the body? Static friction. The friction acts on the body is static, and if there is no other force acting on the body will stop after some time because of rolling friction. Do we understand this, or this is going above and saying bye bye, bye bye, bye bye, I'm going, bye bye? We understand this? Okay, I'll give you 2 minutes to note it down. Shall we move ahead? Okay. Third case. I give it a velocity v, and I give it an angular velocity omega r. Now, angular velocity omega. But then I give it in such a fashion that they are not equal. So They are not equal. That means the point of contact is not at rest. This is known as rolling with sliding. Sliding is also happening here. Do you understand? Sliding is also happening here. Yes or no? And since this is a smooth surface, nothing will stop anything from happening. It will keep on moving and it will keep on rotating. Nothing will stop, and this will like go Simran go, जी ले अपनी जिंदगी. So it will keep on going Simran and it will keep on rolling. It will keep on sliding. V will remain same. Omega will remain same. We understand this? There is no friction to do anything because this is smooth surface. No friction. It will just continuous motion like this. Nothing will happen. Whether V is more than omega r or whether V is less than omega r, it will not be in pure rolling. It will be sliding, rotating as well as sliding, rotating as well as sliding, and will keep on living its life forever. We understand this? Case number 3. We understand this? Shall we move ahead? Now, we come to the case where this is a rough surface. This is a rough surface. And the condition is that V is greater than omega r. Now, if V is greater than omega r, then what will happen at the point of contact? This point of contact, the velocity is V minus omega r, but V is greater and omega r is less. So this will have a tendency to move forward. Yes or no? V minus omega r is positive, it will try to move forward. As soon as it tries to move forward, there is relative motion between this, friction acts. And what type of friction acts? The friction would be kinetic. So remember, wherever there is sliding, the friction is kinetic. Do we understand this? Wherever there is sliding, friction is kinetic. So whenever there is sliding happening, the friction becomes Fk. And as soon as the friction becomes Fk, you know the value of Fk. Fk is always equal to mu k multiplied by n. Do we understand this? Now, what will happen? Now, look at this case. What will happen? Because of this kinetic friction, this velocity will keep on decreasing, but this omega will keep on increasing. Velocity will decrease, omega will increase. Velocity will decrease, omega will increase, and a stage will come where V and omega r will become same. After that, pure rolling will start, friction would become static, and in that case there is no external force. So the value of static friction will also become 0, and this will become Simran and will keep on going, living its life forever. So this body will keep on rolling. The only thing that is going to stop it is what? Is your rolling friction. When the rolling friction slowly comes into the effect, slowly it will stop. Static friction will not stop it. It's the rolling friction that will stop. We understand this? So ultimately, if I leave it with a velocity v greater than omega r on a rough floor, ultimately it will start rolling. And you can do this. Have you gone to a bowling alley? Bowling alley? Where they have this ball and they have small targets and they hit that ball with the target. If you see, first when you release that ball on this bowling alley, first it slides, it slides, and after some time it starts to roll. Have you seen that? That is it. It's a rough surface. They don't make the surface smooth, because if they make the surface smooth, the body will just the bowling ball will just slide and just hit it. They want the body to roll. Let it roll, baby. Let it roll. That will happen. Do we understand this, or this is going up our heads saying bye bye, bye bye, bye bye, bye bye? Now, I do the reverse case. I give it V less than omega r. In that case, what will happen? This point of contact here will have a tendency to move backwards. Yes or no? So the friction, it is sliding. Friction would be forward. As soon as this friction comes forward, reversing will happen. Velocity will keep on increasing and omega will keep on decreasing until a time where V becomes equal to omega r. Then it becomes Simran. Pure rolling starts. That means whenever you have a body and you leave it, giving it any velocity on a rough surface, eventually it will start rolling if the surface is long enough. Do we understand this? Here also the friction is kinetic or sliding, and the value of kinetic friction is mu k into n. After some time, friction will become static. As soon as the friction becomes static, it will become zero because there is no other force. Will keep on rolling. The only thing that is going to stop it is the rolling friction. Do we understand this, or this is going above our thing? Bye bye, sir. Bye bye. Bye bye. Bye bye. This is going above our heads. Eh? Have you seen this? Yes or no? Yes or no? Now again, there are infinite number of cases that I can make. I'll try to make my point in as many less cases as possible. Shall we move ahead? Now let me take you to the case here, which may look familiar with what we were discussing. Now, in this particular case, what I have done is I have given it V is equal to omega r initially. Chalo, let's give V is equal to omega r initially. Because the surface is smooth, let us give it V is equal to omega r smoothly. But now I apply a force on the center of mass or anywhere else. I've taken center of mass, I will also show it at other points. I apply a force anywhere, F. Now what will happen because of this force? Remember, there is no friction to do your job. There is no friction. Now, as soon as I apply the force at the center of mass, what will happen? The velocity will keep on increasing. Yes or no? But this force cannot create any torque about the center of mass. So omega will remain same. Yes or no? When velocity increases, omega should also increase. Else the rolling cannot continue. Yes or no? So here there is no friction. There is no friction to increase its omega, and therefore there is no rolling. It will just slide. No one will stop omega, but V will keep on increasing and omega will remain same. Do we understand this? Omega remains same. Do we understand it? This is going above what I'm saying. Bye bye, sir. Enough. Bye bye. We got this. Now we come to this case. Here, again, there are 1000 cases possible. You just have to understand. In the beginning, I have given V is equal to omega r, and I apply a force F here. Now this surface is rough. And since I have given V is equal to omega, the friction would be static because there is no rolling, there is no slipping. Now, if friction is strong enough, this velocity is going to increase. Now, the static friction can also increase its value from 0 to mu s into n. So, when velocity increases, static friction will also increase, so that omega increases. And it will keep on increasing omega till it can. But eventually, at some point in time, this velocity will become very high and omega cannot become so high. So at some point in time, this pure rolling will stop and the body will continue sliding. Do we understand this? Because friction cannot keep on increasing. This velocity will keep on increasing always, but friction cannot keep on increasing. For some time, it may be able to cope up with this. If it is not able to cope up, it will say, bye, bye, I can't do this. Now it has to slide. So in that case, the body will slide. If you keep on applying that force, keep on increasing the velocity. If you make velocity constant, don't apply the force, then probably rolling will keep on going. Do we understand this, what I'm saying here? So basically, the most important factor here is to rolling for rolling to continue on a smooth surface. The only condition is there should not be any force. You give it V is equal to omega and leave it, it will continue. If you leave anything on a rough surface, after some time, it will start to roll. If there is a force, then we'll have to think in terms of what is going to happen, and that is what we will see. Force applied at different points. What is the role of friction? Remember, if it is sliding, the friction is kinetic. You don't have to worry about anything. You know the value. But if the friction is static, then you have to think, because static friction is variable. It can keep on changing its value. Do you understand this? So I'll end the class here. In the next class, we will see the questions where friction comes and how you can solve those questions when friction comes. Got this? Okay, so I'll take your leave and we will meet in the next class and carry on. And I will try to discuss some of these cases and tell you what is going to happen. Bye bye. Have a good day. God bless you all.